Question 1b and c are really more about working things out than remembering things. The first part, 1b, is about medical x-rays and how much radiation you get from them. So if you look at the table, we've got a whole bunch of different medical x-rays down the side here in the first column, and the radiation dose that you get from having that x-ray. And then in the last column, we've got the number of days of exposure to natural background that corresponds to. So, for example, a hip x-ray would be 44 units of radiation, and that's equivalent to 52.8 days of the exposure you would normally get from background radiation. So what it's asking you to do is to fill in the missing value here, the spine x-ray. How many days is that equivalent to of natural background? Now, when you get a question like this, you need to look at the relationship between the columns in the table. And if you look at the relationship, you'll see that as the radiation dose increases, the equivalent number of days exposure increases, as you might expect. Now, in order to actually work out the number, we need to work out how the two columns are linked. And usually you're looking for a ratio. So if we just take the calculator here and look at this and just check a couple of values, well, if I do the value in this column divided by the value in that column, 2.4 divided by 2 gives me 1.2. Okay, let's just check that that's the same for some other ones. You don't necessarily have to check all the values in the table. If you check a couple and they work, you're probably okay. So let's check the hip x-ray as well. So I'll do 52.8 divided by 44, and sure enough 1.2. So it looks like to get from this column, the radiation dose column, to the equivalent number of days column, all I need to do is multiply by 1.2. So if I take my 140 for the spine x-ray, multiply it by 1.2, and I get the 168 that it says in the mark scheme. Okay, so you're all looking about ratios there. Now the next part of the question is about scientific studies and how they are performed. And it's very important when you get these kind of questions to read very carefully what it's asking you. It's easy to make a mistake about what the question is asking you. So scientists have shown that x-rays increase the risk of developing cancer. The scientists came to this conclusion by studying the medical history of people placed in one of two groups, A or B. The group into which people were put depended on their x-ray record. So that's really important information. If you don't read that, you cannot really answer the question. It says person J has been placed into group A. Place each of the people K, L, M, N and O in the appropriate group A or B. Now because you know it's to do with their x-ray record, you need to look at the similarities and differences between the people to put them into the two groups. So, person J here has had 3 arm x-rays and he's been put in group A. So probably the other people in group A are going to be the people with a large number of x-rays or some x-rays. And if you look at the list overall, we can see there's 3 people with none and 2 other people who've got some x-rays. So the logical thing then to do is to put M, 2 skull x-rays, in group A and O in group A and the others into group B. And that's what the mark scheme says. So you're just sorting the people into the people who've had x-rays and people who haven't. Now, to be able to make a fair comparison, what is important about the number of people in each of the 2 groups studied by the scientists? Very important to read that clearly. Lots of people will miss this word here, number, and talk about other things that might need to be kept the same between the 2 groups. But in this case, they're asking for you to keep the number of people the same. Okay. What data would the scientists have compared in order to come to the conclusion that x-rays increase the risk of developing cancer? Well, again, it's perhaps almost too simple. All they're looking for is, do the people in one group develop cancer when the others don't? So how many people in each group developed cancer is all that they're after. And you need to make sure that you're talking about both groups here. Okay, you can't just say, did the people in group A develop cancer? That's not enough. We need to know that the difference is caused by the fact that the group A people have had the x-ray and the group B people haven't. Now, even when there is a link there, it might not necessarily be that there's a cause, but if you've got a large group of people for group A and group B, then you can be fairly certain that if group A have an increased cancer rate, then it's probably due to their x-rays. Now, the very last part of the question is talking about risk. The chance of developing cancer due to a CT head scan is about 1 in 10,000, and the chance of developing cancer naturally 1 in 4. Now, the important thing to realise about this question is there is no mark for choosing yes or no. The only mark you get for this question is for justifying your answer. So give a reason for your answer. So you can pick yes, and if you pick yes, the reason you want to have is that the benefit of having the scan is greater than the risk, or that the risk is very small, 1 in 10,000, compared to the natural level. So that 1 in 10,000 is not going to make a big difference compared to the 1 in 4. If you chose no, then all you have to do very simply is say that it's not okay to have any additional risk of developing cancer. And that's it.